Hi friends, welcome to Jityo Techno channel. In last class we are discussing up to steps. Before starting pattern making, first of all we have to know about what is pattern. What is pattern? We have to know. Pattern means the replica of the casting. The replica of the casting. That's called the replica of the casting. Replica means you can say the mirror image. The image of the casting. Now we are discussing the pattern size. What is pattern size? Casting size plus minus allowance. So this is the pattern size. This is the basin. We know that this is the basin or cope. This is the sprue, this is the runner, this is the ingot, and this is the mold, right? So here we pour the molten metal, then after here coming to the mold cavity, the molten metal. After solidification of the molten metal, we are got the casting. Casting size maybe is not accurate because maybe during solidification is going to be maybe shrinkage, volume shrinkage, whatever. So that's why we have to providing some allowance. We are discussing after, but in this case here in this mold cavity we are using the pattern. Keep in mind, that's why we are saying that the replica of the casting, that's called pattern. So now we are discuss about the allowance. What is the type of allowance? So first of all having shrinkage allowance. Second is going to machining allowance. Third is going to taper allowance, taper or draft allowance. Fourth one is going to shake allowance. Five is going to distortion allowance. So this is the allowance we are providing on the pattern, because this after solidification this casting, what will happen, maybe this going to shrink or whatever you can say. That's why we have to provide some allowance. Casting size, more size we have to provide or maybe less size, that's called allowance. So now we are discussing about, so listen, these two, shrinkage and machining allowance, these are the major allowance. Keep in mind, major allowance. So now we are discussing about, before discussing shrinkage allowance or allowance, pouring temperature. We are discussing about pouring temperature. What is pouring temperature? Simply we can written PT. What is pouring temperature? The temperature at which the molten metal is going to pour into the mold cavity. That's called pouring temperature. Pouring temperature means the temperature. It is the temperature. In this which temperature we are pouring the molten metal, but this molten metal is going to heat it above melting point. Means you can see pouring temperature equal to melting temperature. Melting point, you can say melting point of any metal plus above, means excess heat we have to provide. I am already discussed this. 150 to 200 degrees Celsius we have to heat it, then we got the pouring temperature. or we can say this temperature also we know that the degree of superheat, degree of superheat means we have to provide the excess temperature, because we are discussing why we are providing excess temperature. The excellent fluidity of molten metal into the mold cavity. So now we are discussing the cooling step. Now we are discussing cooling step from pouring temperature Pt to pouring temperature to room temperature. We are discussing this step. First of all, use pouring temperature. We know that pouring temperature, then pouring temperature, this is the temperature 150 means excess above melting point. Then it is, you know that is the melting point. I am written MP, melting point, or you can say freezing temperature, FT, freezing temperature. You just keep in mind this is also liquid state pouring temperature, as well as in melting point temperature, here also liquid state. So we know that about the sensible heat and latent heat. So here what will happen? Here temperature will be reducing or temperature will be decreasing. That's how we can say it is the sensible heat loss. The temperature will be decreasing. Okay, so after that what will happen? It will be due to latent heat loss. You know that what is the latent heat loss? Due to latent heat, the temperature will be constant but phase will be changing. Means it is the liquid state's melting point, liquid state, but after that due to latent heat loss, means latent heat, what will happen? It will be converted into solid, means freezing, pure freezing, but it started to solid form. After that what will happen? Due to again sensible heat loss, it will be started to and purely solidify. It is room temperature. This is the room temperature. I think it's clear about all of you. So it is the stage 1. You can say, if you consider it is the stage 1, it is the stage 2, it is the stage 3. In figure we are discussing what is this stage 1. It is the temperature and it is the time. So what will happen? We seen that the pouring temperature, we consider that this is the pouring temperature like this. If we consider this is the pouring temperature, so temperature will be decreasing. According to time, the temperature will be decreasing due to sensible heat loss. So what will happen? It is the sensible heat loss. The temperature will be decreasing. Okay, but phase will be what? This phase will be liquid. It is also liquid form. Keep in mind. So this is the pouring temperature. It is the pouring temperature in this region. The Pt temperature, from pouring temperature to this here coming, it is the melting point. I am written here melting point. It is after that due to latent heat. Latent heat means what? The temperature will be constant and phase will be changes. Temperature constant, so that's why like this temperature will be constant. So it is the liquid form. But it is the liquid is started to convert. Temperature will be constant but liquid started to convert into solid. So it is the solid state. After that, due to sensible heat, this freezing or solid is going to started to to solid, and it will purely convert into solid. So due to sensible heat, so here what will happen, it will be coming like this, room temperature. This is the room temperature, room temperature, or you can say it is the room temperature, whatever you can consider. So this is also solid state. Keep in mind, this stage 1, this is stage 2, this is the stage 3. So this 1 and 2 stage, this 1 and 2 state, this stage 1 and 2, stage 1 and 2 is called liquid shrinkage. During cooling, what will happen, the molten metal is going to shrink. During this 1 and 2 stage, what will happen, the molten metal is going to shrinkage. So this is called liquid shrinkage, as well as stage 3 is called the solid shrinkage. During solidification, what will happen, the molten material will be solidified, then it will solid shrinkage. Shrinkage means, what is shrinkage? During cooling or solidification, or you can say during cooling, the volume reduction, the volume reduction or contraction of the material is called shrinkage or shrink, what you can write. So we know that from pouring temperature to this room temperature, each and every stage having shrinkage, right? So this 1 and 2 shrinkage is called, what is this? It's called liquid shrinkage, and the stage 3 is called the solid shrinkage. This liquid shrinkage, this liquid shrinkage compensated by riser, provision of riser. So riser compensated the liquid shrinkage, stage 1 and stage 2. We are compensated by riser, and the solid shrinkage compensated by provision of what? Provision of allowance means what? Allowance, provision of size of casting. Means we think that after solidification we are getting like this. Maybe our desired is going to like this. Maybe it is 250 mm, is the 30 mm you can consider, but after solidification 30 mm. After solidification, what will happen? It may be shrinkage, solid shrinkage. So what will happen? Maybe after solidification we are getting 240 mm, and here we are getting 20 mm. So after solidification we are getting this, our desired like this 250, it is the length, that which is going to 30 mm. So what we will do? We have to provide the allowance, means provision of the size of the casting, provision means we have to provide the excess dimension, linear dimension of the casting. So that's why we are saying provision of casting. So thank you guys. If you have any doubt, so you can comment here.